So this is another in a series of videos in which we're looking at solutions to CSEC Advanced 2024. And in this video, we're looking at question 5. So the first part of question 5 says the region enclosed between the curve y equals x squared plus 1, the x-axis, the y-axis, and the line x equals 2 is rotated about the x-axis through an angle of 360 degrees. Calculate the volume of the solid of revolution that is formed. So I mean, even though this is not necessary, we can just do a little sketch to show the region that we're actually talking about, right? So let me do a little sketch. Or that arrow facing that way. Right? So y, x. Alright, so we're talking about the graph y equals x squared plus 1 between the x-axis, the line x equals 2, rotated about the x-axis. So the graph y equals x squared looks something like this, right? And of course, this point right here would be 1. They say between the line x equals 2. So say x equals 2, y will be equal to 4. So let's say this is x equals 2. X equals 2 would correspond to, well, not 4, but 5. Because it's x squared plus 1. 4 plus 1 is 5. So bounded between the x-axis, the y-axis, the line x equals 2 is rotated about that region there. So the x-axis, the y-axis. So basically, we're talking about this region. Let me identify the region. This region between here, right? So that region is bounded by the x-axis, the y-axis, the line x equals 2, right? That is the region we're talking about. And we're told that the region is going to be rotated about the x-axis to an angle of 360 degrees. And we want to find the volume of revolution that is formed. So what is required of us is to actually just substitute into our formula. And the formula for volume of revolution is V is equal to pi integral of y squared dx between the limits of, say, b and a, where b, of course, is our upper limit and a is our lower limit. Now, if we examine the graph carefully, we can see that x equals 2 is going to be a limit. That's the upper limit. What about the lower limit? The lower limit, of course, is going to be x equals 0, right? Now, in this particular case, we have the function y is equal to, so we have y equals x squared plus 1. But what we need to integrate is y squared. So we can basically say that y squared is equal to x squared plus 1 squared, which you can work out to give x squared plus 1 times x squared plus 1. And we expand our brackets and we simplify. So we're going to say x squared times x squared times 1, then 1 times x squared, then of course 1 times 1. And so this gives us x to the 4th plus x squared plus x squared plus 1, which gives us x to the 4th plus 2x squared plus 1. And so essentially, this is what we need to integrate between the limits of 2 and 0. So we can basically say that this is going to be equal to the integral between 2 and 0. Of course, our pi is to be kept outside. Try not to forget it. So our pi is outside there, right? And so what this will give us is the integral of x to the 4th plus 2x squared plus 1 dx, of course, between the limits of 2 and 1. And having dealt with this part down here, we can actually take it off, right? So let's proceed to integrate that and see what it actually gives us. So, of course, we keep our pi outside, and let's put now a square bracket. When we integrate x to the 4th, we get x to the 5th power over 5. Then we integrate 2x squared, we get 2x cubed over 3. Then, of course, to integrate 1, you simply get x. And because this is a definite integral, we do not need to introduce any integration constant. And we're going to be evaluating this between the limits of 2 and 0. right? So the first case is, of course, when x equals 2. And once again, we must remember to keep our pi on the outside. So we have pi. When x equals 2, this becomes 2 to the 5, which is 32 over 5. Then we have plus 2 times x cubed. 2 cubed, that is 8. And 2 times 8, that is 16. So this is plus 16 over 5. And then this is plus 2. Because all the terms are functions of x, then of course when we substitute 0, we're just going to get 0. So we can basically say that this is going to be minus 0. And we can express this as a simple fraction. Oh, this should be 16 over 3, not 16 over 5. Right? So 16 over 3. Right. So we can go to our calculator and we can then add these up. Sometimes I like to test my mental math. So I will basically express this as two fractions, same denominator. Denominator will be 3. So this, sorry, 15 rather, 15. So this is 96 over 15. And then this, of course, would be 80 over 15. And this is plus 30 over 15. And I would say that 96, so that is 80 plus 30, 110 plus 96, that's 206 over 15. So this is 206 over 15, and of course you have pi, and of course because it's volume, we put cubed units, right? Can this be simplified any further? 206 divided by 15? It possibly can. But of course, if we were to go to a calculator, let me see what the simplest value is going to give us on our calculator. So 32 over 5. So 32 ABC 5. So 32 over 5 plus 16 over 3. And then this is plus 2. So plus 2. And of course, as a fraction, let me see what that gives us. Where is that thing? Where is that thing? Whoa. Anyways, so this calculator is giving me trouble. So basically, I mean, I did work it out mentally. So 32 over 5, that's 96 over 15. 16 over 3, that's the same thing as 8 over 15. And of course, 2 rather, is 30 over 15. So add that up, that's 110 plus 96, that's 206 over 15 times pi, which of course is in cube units, right? So that is what that gives us, right? All right, so that was part A of the question. Now let's move on to part B. What does part B say? Part B says that as a particle moves along a line, my cursor, right? So as a part B. So part B says that as a particle moves along a straight line, its displacement is measured from a fixed point, O on the line. At time t seconds, the acceleration A is given by A equals 24t minus 14. Part 1. Find the expression for the velocity v of the particle, given that when t equals 1, v equals 3 meters per second. Now, we should know the relationship between acceleration and velocity. We should know that acceleration A is equal to the rate of change of velocity with respect to time. So A is equal to dv by dt. Now, we should also remember that essentially integration is the exact reversal of differentiation for the most part, and therefore if we're given acceleration as a function of time and we want to find the velocity v, then v is equal to the integral of a dt. All right? So what do we have so far? We have a as a function of time. A is equal to 24t minus 14. And so therefore, we can say that for part 1, the velocity v is equal to the integral of 24t minus 14 dt, right? And we proceed to integrate. When we integrate t, that becomes t squared over 2. So this is 24 t squared over 2. And then this becomes minus 14t plus our integration constant c. We must remember that whenever we're executing an indefinite integral, we must introduce our integration constant. And in this particular case, we're given some initial conditions that will allow us to find the value of our integration constant c. So let's go ahead and do that. So we now have v equals, now 24 divided by 2, that is 12. So we have 12t squared minus 14t plus c. And what are we told? We're told that v equals 3 when t is equal to 1. So V equals 3 meters per second when t equals 1. So we will substitute these values and we'll solve for our integration constant c. And so we have 3 equals 12 times 1 minus 14 times 1 plus c, right? So what this means is that 3 equals 12 minus 14 plus c. So 3 is equal to minus 2 plus c. And therefore, this tells us that c is equal to 5. So c is equal to 5. And from this, we can therefore say that our equation for the velocity is v equals 12t squared minus 14t plus 5. So this is the velocity as a function of time. Good? All right, so that was part 1. Now, part 2 of the question, part 2 of part B, says that using your answer in B part 1, find an expression for the displacement s of the particle, given that when t equals 1, s equals 10 meters. Now, we mentioned before the relationship between acceleration and velocity, and of course, a similar relationship exists between displacement and velocity. So, because you know that velocity v is equal to the rate of change of displacement with respect to time, then it means that the displacement s is equal to the integral of v dt. So v is equal to ds by dt, and this therefore means that s is equal to the integral of v dt. So we will integrate this expression that we just found over here to find an expression for the displacement s. So say s is equal to the integral of 12t squared minus 14t plus 5. And we integrate with respect to time, and so we see that s is equal to 12t cubed divided by 3 minus 14t squared divided by 2 plus 5t. And once again, we must introduce our integration constant, right? Let us make some space over here since we no longer need this this information. All right, so having integrated, we'll proceed to simplifying our expression, right? And so what we have is this so far. We have that s is equal to, so we say 12 divided by 3, that gives us 4. So we have 4t cubed, then we have minus 7t squared plus 5t plus our integration constant c. Now, what do we do here? We're given this piece of information. We're told that t is equal to 1 when s equals 10. And so we're going to substitute these values and then find our integration constant c. All right? So we say that t equals 1, s is equal to 10. So in other words, when t is equal to 1, s equals 10, and we'll substitute those values into our equation. And so we see that 10 is equal to, now 4 times 1, that is just 4. Then we have minus 7 plus 5 plus c. And so we have 10 is equal to, now 4 minus 7, that gives us negative 3. Negative 3 plus 5, that gives us 2. So 10 is equal to 2 plus c, which therefore implies that c is equal to 8. And therefore, we can say that, right? We can say that s is equal to 4t cubed minus 7t squared plus 5t plus 8. And this right there is our expression for the displacement s as a function of time t, right? So that's that part of the question there. Good. So that was part 2 of B. And now we'll just move on to part C, all right? Now, part C of this question says the gradient function of the curve C is given by 7 minus 2x. If the curve passes to the point 3,8, find the equation of the curve. Now, it's a function of x, and we're given that the gradient function is a function of x. And we're told that the curve passes through a particular point, and we're told to find the equation of the curve. So what do? We simply say that dy by dx is equal to, 7 minus 2x. And what next do? We're going to separate our variables. So say separating our variables. So this means that we get all our x's on one side and our y on the other side. So separating our variables, we see that we get that dy is equal to 7 minus 2x times dx. And then what next do? We integrate both sides. We then integrate both sides. Right? So integrating both sides, we're going to get that the integral of dy is equal to the integral of 7 minus 2x dx. And we proceed. Now when we integrate dy, we simply get y. And when we integrate on the right-hand side, integral of 7 minus 2x, this becomes 7x. And we have minus 2x squared over 2 plus our integration constant c. So we can basically say that y is equal to minus x squared plus 7x plus c. Because of course these 2's will cancel, so 2 into 2 goes 1, 2 into 2 goes 1. And because we put it in the order of descending terms or descending powers, then we have y equals minus x squared plus 7x plus 2. Now, what are we given that will allow us to find the value of c? We're told that the curve passes through the point 3, 8. So the curve passes through the point 3, 8, and what this therefore means is that y equals 8 when x is equal to 3. And therefore we can say that 8 is equal to minus 3 squared. Now you have to be careful. This is not minus x all squared, but negative times the square of x. So because x is equal to 3, this is minus 3 squared, right? Then we have plus 7 times 3 plus c. So we have 8 is equal to minus 9 plus 21 plus c. 8 is equal to 12 plus c, and therefore c is equal to 8 minus 12, and so c is equal to negative 4. And having found the value of c, we can now therefore say that the equation of our curve is y is equal to minus x squared plus 7x minus 4. And this is the equation of our curve. This is the end of the question, part C, and the end of question 5 from CSEC ADMAS 2024.